Friends, in this segment we'll discuss about parallel form realization of IR filter. Now friends, in the previous segment we have discussed about cascade form realization, in which we have seen the several IR systems are connected in cascade with each other. That means simply their transfer functions were connected in series with each other. Now in this case the name itself indicates parallel. That means here the different IR systems, they will be connected in parallel with each other. That means in this case their transfer functions are going to be added with each other. Now in order to get a system transfer function which has a several transfer functions, those who are added with each other, so in general we should go for a method that is called as a partial fraction expansion. And hence, while realizing IR filter using parallel form, the very first step will be we should go for partial fraction expansion. So let us consider that I am having a transfer function of IR filter which is given by partial fraction expansion, that I am writing as h of z is equal to c plus k is equal to 1 to n ck upon 1 minus pk into z inverse. Now we are writing this. The reason behind this one is what? Generally, partial fraction expansion, if you see, it will have terms like this one: a upon 1 minus z inverse plus b upon 1 minus or maybe 2 minus z inverse, and so on, that we are writing simply. So we got an equation in terms of partial fraction expansion. Now we'll try to simplify this equation. So I can get this as c. Simply we'll put the values from 1 to n. We'll get this term as c1 1 minus p1 z inverse, first whole coefficient, c2 1 minus p2 z inverse, plus so on to the last term. If we consider this is cn upon 1 minus pn z inverse. And the next step, I will write h of z as a ratio of output by input, that is y of z by x of z. And this term we'll consider as it is c plus, let this is my first system transfer function, that will assume h1z, this is h2z, and let this is the last one as hn z. Now this equation simply indicates there are certain terms as output y of z and x of z. If I multiply, we'll get the same equation as c xz plus h1z into x of z plus h2z into xz plus so on. This is my hnz into x of z. Now we'll realize this equation using direct form to realization. You can see there are several systems h1z, h2z, hnz. They are connected with each other. That is nothing but they are being added with each other. So we'll write this. As usual, the process will be same. Here we'll write the input as x of z, and here we will get at this side the output as y of z. So you can see y of z is a function of c into x of z. That means we need a multiplier with c, that becomes c into x of z. Next h1z, so we'll consider one block here which is h1z. Now this h1z is again multiplied with x of z, so this is multiplied with x of z, and its output now becomes h1z into x of z. Similarly, if you add another term as h2z, this becomes h2z into x of z, and so on to the last term which we write as hnz. So this is again a multiplication of hnz with x of z. Now we'll add all these terms. So starting with these elements, this is adder, and here we'll place one more adder. These are the terms, and these all are added starting with c into x of z. And addition of all these results into y of z. So this is my x of z and this is our y of z. So you can see these all systems are connected in parallel with each other. Hence it becomes parallel form realization of IR filter. Now let us see one example on this one. That we'll assume that this is my example. You can see obtain parallel form realization of the given system transfer function. H of z is given in this form. So the first step we should write is that we'll write step number 1 is we will apply partial fraction expansion. So before applying partial fraction expansion, we'll take this z in the denominator of h of z so that we can get a constant term. You can see this is the simplified form c plus all these terms. So in order to achieve it, first step I will writing here as h of z by z is equal to 3 into 5z minus 2 divided by z plus 1 by 2 into this is 3z minus 1. Now in the next step I am taking 3 as a common from this term so that we'll get the term as z minus 1 and this is z plus 1 by 2. This is required for partial fraction expansion. So if I take z as, that is 3 as common from the denominator term, we'll get this term as 3 into z plus 1 by 2 into z minus 1 by 3. Now this 3 will get cancelled and we'll get the equation h of z by z like this one. Now we'll apply partial fraction expansion. I am writing this term hz by z is equal to 5z minus 2 divided by this is z plus 1 by 2 into z minus 1 by 3 is equal to, we'll simplify this as a by z plus 1 by 2 plus b divided by z minus 1 upon 3. Now by the partial fraction expansion we can write this is 5z by minus 2 divided by z plus 1 by 2 z minus 1 by 3 is equals to, we'll cross multiply the terms, plus b into z plus 1 by 2. Now it is divided by z plus 1 by 2 into z minus 1 by 3. So this denominator terms will get cancelled and we'll get this equation as 5z minus 2 is equal to a into z minus 1 by 3 plus b into z plus 1 by 2. Now we'll try to obtain the values of a and b by putting some values of z. So considering this, first we'll try to find the values of a. Now to find a, one thing is sure, b should be 0. So b becomes 0 if and only if z is equals to minus 1 by 2. So if I put minus 1 by 2 plus 1 by 2, it becomes 0. That means we'll write here, to find a, we'll consider let z is minus 1 by 2. So this side, this becomes 5 into minus 1 by 2 minus 2 is equal to a into, this is minus 1 by 2 minus 1 by 3 plus b into minus 1 by 2 plus 1 by 2. Definitely this term is going to be 0. Now we'll simplify this. This is minus 5 by 2 minus 2 is equals to a into, we'll cross multiply these terms. This is minus 3 minus 2 minus 5 by 6. Again this one cross multiplication, it will hold minus 5 minus 4, that means I'm writing directly minus 9 by 2 is equal to a into minus 5 by 6. Now this 2 and this 6 will remain 3. This minus minus will get cancelled and we'll get this equation a is equals to 9 into 3, 27 by 5. So this is our first coefficient as 27 by 5. Similarly, we'll find b also. That term we'll write here. Now to find b, a should be 0 and now a becomes 0 if and only if z is equals to plus 1 by 3. Now to find these values, you can also equate this to 0, that is z minus 1 by 3 is 0, so z becomes plus 1 by 3. So we'll write, to find b, let z is equals to plus 1 by 3. Now if I put z is equals to plus 1 by 3 in this equation, we'll get this is 5 by 3 minus 2 is equal to a, definitely 0, will come across b into 1 by 3 plus 1 by 2. Now the same process, cross multiplication, 3 into 2 will be minus 6 minus 6, 5 will be minus 1 by 3 is equals to b into cross multiplication of this will be 5 by 6. So 3 2s are 6, that means this is 5 by 2. So b becomes minus 2 by 5. This is our second coefficient as minus 2 by 5. Now once you got these coefficients, we'll come across this equation, that is, you can see h of z by z is equals to a by this one. So I'm writing this term here, h of z upon z is equals to a is 27 by 5 divided by z plus 1 by 2 minus b's value is minus 2 by 5, so this is minus 2 by 5 z minus 1 by 3. Now in order to realize this using direct form to realization, we need a delay element, that is z inverse. So one has to obtain all these terms in the form of z inverse. That may be possible if I divide this entire equation by z. You can see if I divide this by z, this z will get cancelled. Similarly this like this will get cancelled. So if I write this, we'll get h of z is equals to 27 by 5 upon, you can see z by z will be 1 plus 1 by 2. If I divided this again by z, that becomes z inverse minus 2 by 5. Again the same process, z by z will be 1 minus 1 upon 3 into z inverse. That means now we got this equation in terms of delay elements at z inverse and z inverse. Now the next step is we'll realize this using direct form to realization. So you can see I'm just simplifying this equation now. First we'll try to implement this using direct form to realization, and then we'll come across this one. So for a better simplification, I will rewrite these equations. H of z is equals to 27 upon 5 1 plus 1 by 2 z inverse minus 2 by 5 1 minus 1 by 3 into z inverse. Now we'll realize these equations using direct form 2. So first we'll come across this one. This is our h1z and this is h2z. These two systems are added with each other. Now for this case, you can see only one delay element is required. That means we'll take this is the first delay element as z inverse, and only one adder is required. Now for the z inverse, here it is plus 1 by 2. Now by our method, we have seen this, it should be minus 1 by 2. So remember, whenever pole coefficients are positive, in realization they becomes negative, and it should be added. So we'll add one adder here, or simply we'll keep one adder here, and let this is x1, and because this is h1, so and they are being multiplied with 27 by 5, so we'll multiply this by plus 27 by 5. This is our first system, h1z. Now we'll come across the second system. This is h2z. They are connected in parallel with each other. So another term we'll take, here it is. I am assuming that this is my second system transfer function, z inverse, like this. Now this is multiplied with minus 1 by 3. That means here this coefficient becomes plus 1 by 3. Adder is placed here, and this is again multiplied with minus 2 by 5. Now these two systems should be added with each other, so we can assume this is output of first system, and this is nothing but output of second system. These two are added with each other. Now as far as this part is considered, for this entire system the input is going to be common. That means what can we do is we'll combine input, and let this is the input. If you see properly, this is x of n, and this is our output as y of n. Now you can see we can erase this x1n. So you can see these two systems, h1z and h2z, that is nothing but their transfer functions are added with each other. So this becomes the parallel form realization. Parallel form realization. Now this is one kind of example that we have seen. We are having another type of example. So these kinds of examples can be asked in the university examinations that obtain a parallel form realization. Now let us see that example. Now this is the second example, that is obtain parallel form realization for this. Now in many of the books they have used long division method to simplify this, and then they applied partial fraction expansion. So better way, we will try to simplify this in another manner, and then we'll apply partial fraction expansion. The simplest way is we should write this in terms of z only. So I'm writing these terms 1 plus 2 by z plus 1 by z square divided by, this is 1 minus 0.75 by z plus 0.125 by z square. Now we'll try to multiply or take LCM as z square. So this equations becomes z square plus 2z plus 1 divided by z square upon z square minus 0.75z plus 0.125, and it is divided by z square. So that z square will get cancelled and we'll get this equation. Now we'll follow the same method that we have seen in previous example. To apply partial fraction expansion, now we'll try to divide both the sides by z, so that this equation holds. H of z by z is equals to z square plus 2z plus 1 divided by, this equation is z square minus 0.75z plus 0.125, and this is multiplied with z because we are dividing both the sides by z. Now we'll try to factorize the denominator term because it is in the form of ax square plus bx plus c. So first we'll find factors of 0.125. So by factorizing this, or you just simply put those values in the calculators, we'll get the factors as 0.5 and other factor is 0.25, and both should be minus. Here it is plus, the multiplication will be plus and their addition will be with sign minus. So this equation holds z square plus 2z plus 1 divided by z into z minus 0.5 into z minus 0.25. This is our equation. Now we'll write this in terms of partial fraction coefficient, that is, I can write this term as a by z plus b by z minus 0.5 plus c upon z minus 0.25. So now we'll simplify this. So I can write directly these terms as z square plus 2z plus 1 is equal to, just taking the terms as LCM, we can write this is a into z minus 0.5, z minus 0.25 plus b into z into z minus 0.25 plus c into z minus 0.5. Now we'll try to find the coefficients like a, b and c. So to find those equations, we'll try to solve this by finding either a, b and c. Now first, to find a, b and c should be 0. Now to make b and c as 0, you can see here it is multiplied with z and this is multiplied with z. So we can assume z as 0. So let us put those values in that equations. So you can see I'm writing it here. To find a, put z is equal to 0. Now putting z is equals to 0 in above equation, we'll get this term LHS 0, 0 and this 1. So this is 1 is equals to a into 0 minus 0.5. So this is minus 0.5 into 0 minus 0.25 will be minus 0.25 plus b into 0, 0, c into 0 will be 0. That means all these terms are 0. So you can write this term. It is nothing but a is equals to 1 divided by minus into minus will be plus 0.5 into 0.25 will be 0.125. So you can write this simply as 1000 upon 125. That is nothing but 8. That means our first coefficient value is a is equals to 8. Now we'll find b and z, or c we can see again. Now to find b, a and c should be 0. Now a and c will be 0 provided that in both the terms we are having z minus 0.5, z minus 0.5. So I can consider z is equals to 0.5. So we'll write, put z is equals to 0.5. So this equation holds LHS z square. So this is 0.5 square plus 2 into 0.5 plus 1 is equal to A. This is 0.5 minus 0.5, 0. That means A term is 0, C term is 0. So we'll write only B's term. That is B into 0.5, 0.5 minus 0.25. So if you put those values simply in your calculators, so we'll get B is equal to, if I'm correct, this value is 18. So we got this value as 18. Now similarly, we'll try to find C. So you can simply write here, to find C, we have to assume some values of Z. Now you can see, as far as A, B, C are considered, to find C, in A and B we are having common terms as Z minus 0.25, Z minus 0.25. So you can assume Z as 0.25. Now again the same procedure, simply put those values as, this is their 0.25 square plus 2 into 0.25 plus 1 is equal to, A and B are going to be 0. We'll come across C only, C into 0.25 into 0.25 minus 0.5. If you simplify those values, or just putting those values in the given equation, we'll get this value as C is equals to 25. Now friends, if I got these values of A, B, C's, next step we'll consider H of Z by Z is equals to, we'll come across this, we have written already that part, A by Z plus B upon this one. So I can write A is nothing but 8 divided by Z plus B is 18 divided by Z minus 0.5 plus C is 25 divided by Z minus 0.25. Now once you got these equations, now the next step is entire terms should be divided by Z. So we'll get this equation, H of Z is equals to 8, Z by Z will be 1 plus 18 divided by 1 minus 0.5 Z inverse plus 25 divided by 1 minus 0.25 into Z inverse. Now you can see we got the same form of equations, constant term H1Z and H2Z, they all are they are being added with each other. Now the next step will be, we'll simply write them in parallel form. So starting with the first term, that is 8. So the first term we'll assume as 8. Next you can see 18 upon 1 minus 0.5 Z inverse. So we need one delay element here. So simply I am taking this as Z inverse. Now this is multiplied with minus 0.5. So this becomes 0.5, that is plus. And only one adder is required. So we place one adder here. This is the term. This is our H1Z. Next, coming to the point of H2Z, again we need one delay element. So this is Z inverse, one adder is placed along with this. Now this is multiplied with minus 0.25, so it becomes plus 0.25, and this is the term. Now for H1Z we are having a gain as 18, so this is multiplied with 18, this is multiplied with 25. Now these three terms, or this all systems, will have a common input as x of n. Now in next step we have to simply add them. So you can see this is adder, these three systems are going to be added with each other. This is output of this second system, they are being added. So you can assume this is H1Z, sorry, this is H2Z, this is H1Z, and the first one is constant, and finally you will get the output as y of n. So this is direct, sorry, we can say that parallel form realization of IR filter. I hope you understood those concepts. If you like my videos, please subscribe my channel. Thank you.